Determine the oxidation number of the element underlined in each of the following. So we don't know the chromium, but there are 2 of them, so we'll go 2x plus, we do know that there are 7 oxygens and oxygens are minus 2, and the entire thing is equal to minus 2, and therefore x turns out to be plus 6. The next one, I don't know the iron, so I'm going to go 2 times I do not know, plus 3 times I do know oxygen at minus 2, and this is a neutral substance, there's nothing up there, so it's equal to 0, and the x comes out at plus 3. Next one is going to be it's just x, because there's only 1 copper here, plus sulfate. The whole sulfate ion is 2 minus, so I'm going to go minus 2, and the whole thing is equal to 0, so the x comes out at plus 2. And finally we've got something I don't know, plus 4 times negative 2, and altogether that's equal to negative 3, and therefore it comes out at plus 5. The next one asks me to assign oxidation numbers to the following. So I need to do it for every single element, not wherever I feel like it. Every single element needs an oxidation number. So let's start off at the very beginning, and we're going to say that anything on its own is 0. The hydrogens are plus 1. Yes, there are 2 of them, and you land up with plus 2 minus 2 equaling 0. But those are working numbers. That is not the oxidation number. The oxidation number is plus 1. Then you're going to have iron on its own, zinc on its own, 0, 0. The chlorine is not minus 2. Again, that chlorine is minus 1. There are 2 of them, so it's minus 2 in the calculations, but it is minus 1 as an oxidation number, minus 1 as an oxidation number, and then you land up with the iron being plus 3 and the zinc being plus 2. Again here, aluminium and iron are on their own. Yes, the whole nitrate ion is minus 1. However, it didn't ask you to decide what you felt like assigning it to. You had to assign it to every element. So you need to work out what the nitrogen and the oxygen are in the nitrate ion. So it's going to be, I don't know, plus 3 times minus 2 is equal to the whole thing minus 1, and I land up with x being equal to plus 5 in that story. And it's the same for the other nitrate ion. There are 3 of those, so I'm going to say I don't know with the aluminium, even though it's in group 3, plus 3 times minus 1 for the nitrate ion, and I get plus 3. Here, I don't know, plus 2 times minus 1 is equal to plus 2. Then it says, use oxidation numbers. In other words, I want to see the oxidation numbers to identify the element that has been oxidized, if any has, in each of the following. Circle the element that has been oxidized. So the first thing is I want to see the oxidation numbers. So anything on its own is 0, and the bromide is going to be minus 1. There are 3 of them, and therefore it's plus 3 on the aluminium. You can't write minus 3 here. You have to write minus 1 over there. Then what do I see? I can see that the bromine has gone from 0 to minus 1, so that has been reduced, whilst the aluminium has gone from 0 to plus 3, so that has been oxidized. So what got oxidized? The aluminium. Next one is cobalt chloride. The cobalt on its own and the chlorine on its own is 0. Chlorine is negative 1. I then have some calculation numbers of minus 2 plus 2, but the chlorine itself is negative 1. That's a calculation, and I can then see that the chloride was oxidized to chlorine, and the cobalt 2 plus was reduced to cobalt, and therefore it is the chloride, the Cl minus ion, that has been oxidized. Carrying on, use oxidation numbers to work out which one has been reduced, and circle that. And copper 2 plus, minus 1, 0, 0. Here again, this hydrogen is not plus 2. It's plus 1 as an oxidation number. Plus 2 is a calculation number. 0, 0, minus 2, minus 2. And then you're going to land up with working out using minus 2 times 3 and then plus 6 divided by 2. Minus 2 times 3 minus 6 divided by 2 plus 3. And you land up with your oxidation states of all of those. And then you can see quite clearly that the copper got reduced from plus 2 to 0, and the iron got reduced from plus 3 to 0. Assign oxidation numbers to each element in the following. hydrogen's plus 1, chlorine's minus 1, oxygen minus 2 plus 1, and this is the one that was particularly tricky. Chlorine should be minus 1, of course it should, but this whole thing has to equal 0. So potassium's plus 1, it's only got 1 electron that it can do anything with. Oxygen is always minus 2, and there are 3 of them. This whole thing has to equal 0, and then it turns out that you need a plus 5. Is it reasonable that chlorine could be plus 5? Well, let's see. 1, 2, 3, 4, 5, 6, 7. It is quite possible that just these electrons over here are going to participate in bonding, and that pair would remain unparticipated in bonding. It's not likely, it's not common, but it can happen, and that's what happens in the chlorate ions. So it's one of the weird exceptions that you need to be aware of. We've done those. Then looking over here, identify the oxidizing and reducing agent in each of the following. Now this one, I wasn't strict about what you did with oxidation numbers because it doesn't say using oxidation numbers. So I'm only looking at the fact that did you identify what got oxidized? Well, not even. What got reduced? And I'm able to do that fairly easily. 0, 0, 0, 0, minus 1 plus 1, minus 1 times 2 plus 2, minus 1 times 3 plus 3, so you can see exactly. Once you've decided what got oxidized and what got reduced, whatever got oxidized is a reducing agent, and whatever got reduced is an oxidizing agent. This is the one which most people manage to get wrong. You can't say silver is the oxidizing agent, because silver's over there. This is Ag+, or the silver ion, that is the oxidizing agent.